This is Pre-Algebra Chapter 2.1, Properties and Operations. In this lesson, we're going to learn to use properties of addition and multiplication so that we can later apply these to our algebra studies. We start this lesson with a brief vocabulary lesson. In the English, the term commute means to change locations. The related math term, commutative, has a similar meaning. In mathematics, it means that it lets us change the positions of numbers in a sum or a product. Next, let's look at associate and associative. In English, the word associate means to group together. The related mathematics term, associative, means that we can group numbers in a sum or a product together. Both addition and multiplication have commutative properties and associative properties. Let's learn those now. The commutative property of addition means that in any sum, we can add the numbers in any order. As this example shows us, we can add 4 plus negative 7, and it's exactly the same as negative 7 plus 4. When we translate that to algebra, it means that A plus B is the same as B plus A. All right, now let's go to the associative property of addition. When we change the groupings of numbers in a sum, it doesn't change the sum. Again, looking at our example here, 9 plus 6 plus 2 is the same as 9 plus 6 plus 2. When we translate that to algebra, that means we can take A plus B plus C or A plus B plus C, and we're going to get the same answer. Okay, let's move on to multiplication. In a product, we can multiply numbers in any order. That's the commutative property. So if we take 8 times negative 5, we're going to get the same answer as if we take negative 5 times 8. In algebra, that translates to A times B is the same as B times A. The associative property of multiplication tells us that changing the groupings of the numbers in a product will not change the product. So we can multiply 3 times 10 and then multiply that sum by 4, or we can take 3 and multiply it by the product of 10 times 4. We're going to get the same answer. In algebra, that means we can multiply A times B and then multiply that product by C, or we can multiply A times the product of B and C. We'll get the same answer regardless. Fairly clear, correct? Here's an example problem that lets us use the properties of addition. So let's say we buy a portable CD player for $48. We also purchase rechargeable batteries with a charger for $25 and a CD case for $12. What is the total cost? What did we spend overall? Okay, so our total cost we know is the sum of our three prices. So let's use the properties of addition to group together prices that are easy to add mentally. All right, so I'm going to take 48 plus 12 first, because that gives me a round number, 60, to work with. Then I'm going to take 60 plus 25. Again, that's an easy addition problem to do mentally, and we get a final answer of $85. However, would it matter if we were to add these numbers together in a different order? Would it change our answer? Well, let's try it and find out. Well, let's try 48 plus 25. See, that's going to give us $73. And now let's take 73 plus 12, and look at that, $85. So no, it doesn't matter at all in which order I do the problem, I'm going to get the same answer. Now let's work through a problem that allows us to use the properties of multiplication. Let's evaluate 4xy when x equals negative 7 and y equals 25. So we begin the problem by substituting negative 7 for x and 25 for y. So we can immediately see that we're going to be multiplying all the way through this problem. 4 times negative 7 times 25. So the commutative property of multiplication tells us that it does not matter in which order we choose to multiply these problems. And the associative property allows us to regroup them in any way that we like that makes the most sense for our brains to do quick mental multiplication. So I'm going to organize the problem like this. 4 times 25 times negative 7. Because I know that 4 times 25 is 100, times negative 7 gives me a very easy answer of negative 700. So there is our final answer. It would not matter if we chose to multiply 4 times negative 7 and then take that product, 28 times 25, it would give us the same answer. However, this way works better for my brain because it lets me do the quick mental math of 4 times 25. All right, now test these problems on your own using the commutative and associative properties of addition and multiplication. Record your answers in your homework notebook, and we'll review them together tomorrow. Our next idea is to use the properties to simplify variable expressions. For example, this expression, x plus 3 plus 6, can be simplified. So x plus 3 plus 6. We can use the associative property of addition to simplify this problem. X, the variable, is one type of term, and 3 and 6 are both numerals, numeric terms. So we can actually combine those using the associative property of addition. So this can be simplified to x plus 9 because we can add 3 and 6 together to simplify the expression. Here's another example. Let's try 4 times 8y. We can use the associative property of multiplication to simplify this problem as well. We can put the like terms together, 4 times 8, and get an answer of 32. So 32 times y would be the simplified expression. Now try simplifying these 4 problems on your own. Record your answers in your homework notebook. Now let's look at the identity properties. There is an identity property of addition and an identity property of multiplication. The identity property of addition tells us that the sum of any number and the additive identity, which is 0, always equals the number. For example, if we were to take negative 6 plus 0, we would get an answer of negative 6. This translates to algebra because any variable added to the additive identity will simply equal the variable. A plus 0 would equal A. Let's look at the identity property of multiplication now. The identity property of multiplication tells us that any number multiplied by the multiplicative identity, which is 1, is the number. For example, 4 times 1 will equal 4. That relates to algebra because any variable times 1 will simply equal the variable. So these properties of 0 and 1 are called the identity properties. And in this case, the numbers 0 and 1 are called identities. Let's examine these examples and identify the properties that each illustrates. A tells us that negative 5 times 1 equals negative 5. That is the identity property of multiplication, correct? Now B shows us that 2 plus negative 9 is equal to negative 9 plus 2. That would be the commutative property of addition. It doesn't matter in which order we add, we get the same result. C, y squared plus 0 equals y squared. That's the identity property of addition. And finally, D, 2 times p times q is the same as 2 times p times q. That's the associative property of multiplication. All right, let's move on to the last idea in this chapter, unit analysis. The final idea in our chapter, unit analysis, lets us find a conversion factor that converts a given measurement to a different units. It uses the identity property of multiplication to help us figure out how to switch from one unit to another. An example of a conversion factor would be this, 1 foot over 12 inches. We could also rewrite this as 12 inches over 12 inches being equal to 1. So we're going to use this identity property of multiplication to tell us that multiplying a measurement by a conversion factor does not change the measurement. Let's do a problem together to show how this works. The Steel Dragon 2000 is the world's longest roller coaster. Its length is 2,711 yards. How long is the roller coaster in feet? We're going to solve this by finding a conversion factor that changes yards to feet. So the statement 1 yard equals 3 feet gives us 2 different conversion factors. The first is 1 yard over 3 feet. The second is 3 feet over 1 yard. These are exactly the same thing. Unit analysis shows us that a conversion factor that converts yards to feet will have feet in the numerator and yards in the denominator. Let me show you how that works. So we're going to take a number of yards, and we want to multiply it by a conversion factor that will change to feet. So we want those yards to cancel. So we want the yards in our denominator and our feet in our numerator. Therefore, the conversion factor that we want to use to solve this problem is this one, 3 feet over 1 yard. Now we solve by setting up the problem like this. 2,711 yards times 3 feet over 1 yard. Now we can cancel out our yards and solve the problem. So we're going to multiply 2,711 times 3 to get an answer of 8,133 feet. So the roller coaster is 8,133 feet in length. And here is your final exercise for this lesson. Convert 400 centimeters to meters by using a conversion factor. We'll go over this tomorrow, as well as some additional problems on properties and converting units. Have a great night.